In this particular question, a particle of charge 2 microcoulomb, 2 microcoulomb and mass 1.6 gram. So charge is given Q equal to 2 microcoulomb, mass is given 1.6 gram. So 2 microcoulomb, that means 2 into 10 to the power minus 6 coulomb, and this is 1.6 into 10 to the power minus 3 kilogram, and moving with a velocity of 4 ik meter per second. Okay, initially the particle is moving with a velocity, that means its initial velocity is along x-axis, which is nothing but 4 ik meter per second, and which is nothing but at time t equal to 0, the particle enters in a region having an electric field. Electric field is given 80 ik plus 60 jk. So that means here the particle is not having any initial velocity along y direction, clear, or along y-axis. No velocity along y-axis, the initial velocity along y-axis, that means it is 0. So this is what the situation is. Now at time t equal to 0, the particle enters in a region having electric field. Electric field is given E equal to 80 ik plus 60 jk Newton per coulomb. So this is the electric field which is present in xy plane. So what it is asking, find the velocity at t equal to 5 seconds. So what is the velocity? V equal to how much? Clear. So that means you have to find out velocity V in vector form, that is Vx ik plus Vy jk. Clear. So that we have to find out, that means we have to find out the x and y component of the final velocity, which will be at t equal to 5 seconds. So here in this particular case, let me draw the electric field first. So assume that this is the electric field, and this is the situation over here. This is right, this over here, this is the electric field which is present in xy plane, and at t equal to 0, the charge particle enters. Initially the charge particle was moving in along x-axis with some speed that is 4 meter per second along x-axis, and at time t equal to 0, it starts moving, starts entering the field. So at time t equal to 0, it starts entering the field. So here in this particular case, the speed is again 4 when it enters, 4 meter per second. So as soon as it enters, the electric field acts upon it. So as it acts, then electric field, it will experience the electric field, and due to electric field, it will experience some force. So what will the force due to electric field? So force due to electric field will be how much? F equal to Q into E. So Q is given 2 microcoulomb. So 2 into 10 to the power minus 6 into electric field is given 80 ik plus 60 jk, this much. So finally over here, what will be getting? So it will be 160 ik plus 120 jk whole into 10 to the power minus 6, this much Newton. So it will experience a force of this much Newton. Okay. Now if it is experiencing some force, and we have to calculate the velocity, that means as it is experiencing some force and it is having some mass, then it will be accelerating. So what will be the acceleration of this charged particle? So acceleration A equal to F upon m. So that means force is, already we know the force, that is 1.160 ik plus 120 jk whole into 10 to the power minus 6 divided by acceleration, that mass of the object is 1.6 gram, that means 1.6 into 10 to the power minus 3 kg. Clear. So what we'll be doing over here, so 160 divided by 1.6, so it will be 100. It will be 100. So 10 to the power minus 3 will goes up, so it will be 100 I cap plus this one will be, particularly it will be 70, approximately 75 j cap whole into 10 to the power minus 3. So this much meter per second square. This will be the acceleration of the charge particle. As we have already taken the in SI units, so finally directly we can write. No need to check the unit whether it is we are getting meter per second square or not. Clear. So here in this particular case, acceleration is getting, so we are getting the acceleration is this much. That means uh, the x component of acceleration is how much? It is 100 into 10 to the power minus 3 meter per second, and acceleration along the vertical direction is how much? 75 into 10 to the minus 3. Clear? This is the acceleration, magnitude of acceleration along x and y axis. Clear? Initial velocity is 4 meter per second. Initial velocity is 0. Clear? And this is the scenario at time t equal, means time t equal to 0. So what is the final velocity at t equal to 5 seconds? So at t equal to 5 seconds, final velocity vx equal to ux plus ax into t. So ux is 4 plus x is 100 into 10 to the power minus 3 into t is 5. Clear? So this particular value, if we calculate, so it will be equal to 4, and here this particular will be, this is plus here how much we can take. So it will be 10 to the minus 2, 10 to the minus 10 to the 2, 10 to the minus 3, so it will be 10 to the minus 1. So 5 into 10 to the minus 1, or 5 upon 10. So we can write 5 upon 10. Okay, so 1 by 2, 0.5. So it will be 0.5. That means it will be 4.5. Here, final velocity we are getting 4.5 meter per second. And similarly over here, at t equal to 5 second, what will be the final velocity that we want to calculate? So final velocity equal to vy equal to uy plus ay into t. So uy is 0 plus ay we are getting 75 into 10 to the power minus 3 into time is 5. So it will be how much will be getting? 5 5, and it will be 37. 75 into 10 to the power minus 3, or it will be with approximately 0.375. Clear? So approximately this much value will be getting. So 0.375 meter per second. Okay. So this is the case, 0.375 meter per second, and finally over here the final velocity v will be equal to vx I cap plus vy j cap. So vx is 4.5, I cap plus vy is 0.375 j cap meter per second. So this will be the final answer.